Hi friends, welcome to GMAT Points video series. In this particular video, I'll be discussing the data insight section. What is there in the data insight section? For a lot of students, this is the one section that they are the most worried about because they don't have much information about it. In GMAT's guide, there is some explanatory information, but still there's a lot of misinformation or lack of information about data insights, particularly because this is a new section. A lot of you are worried, I know that. So let us take a deep dive into the data insight section. Let's take a look at all the different types of sets that come, and let's try to identify how to actually do well in these type of questions. So let's get started. What is essentially expected in the data insights question? What kind of sets are there in data insights question? So data sufficiency is one part of the data insights question. Many of you might already be familiar with because it was part of GMAT OG. The data insights data sufficiency questions are very common to like many other entrance exams also. So many of you might already be familiar, but if you are not familiar, I'll explain what exactly is there in data sufficiency. So in data sufficiency question, there is some information that is provided at the start, then a question is asked. The information that is provided at the start is not sufficient to answer the question that is asked. Now you will need some additional information to actually answer the given question. So then you will have statements A and statements B, and you have to essentially infer whether the information contained in statement A or in statement B is sufficient to answer the given question. I'll take an actual example, a concrete example, but once the point essentially over here is you have to determine in data sufficiency what is the missing information, and you have to determine whether that missing information is available in statement 1 or statement 2. If it is there, if the missing information is supplied by statement 1, you have to mark one answer. If it is supplied by statement 2, you have to mark another answer. If it is supplied by both, you have to mark another answer. If neither of them supplies it by themselves, but together they supply the missing information, again then there's one option that is corresponding to that. But here the entire topic revolves around identifying the missing information and figuring out whether a given statement or set of statements provide the missing information. What is multi-source reasoning? This I felt is the hardest part of the data insight section because there is a huge amount of information that is given. Much of it is really irrelevant to the question being asked. In general, how do you actually solve multi-source reasoning questions? The point of multi-source reasoning questions is that when you have so much information that is given to you and they're like tabs full of information, the point of multi-source reasoning is testing whether you get overwhelmed by information, or you are able to say that, okay, if this is the question that is asked, this is the relevant information to answer it. You find the relevant information, crunch that relevant information, and then make the right choice. So here, what is being tested in multi-source reasoning? It is whether you can find and infer from relevant information when excessive information is given. Now, what is exactly required in graphs and tables? So, graphs interpretation and table interpretation is pretty similar. In both cases, you have to determine whether a statement is true. In the case of table information, you will be given a table, and based on the table information, you can essentially sort the table according to any column, and then you will be asked, based on the table, you will be given 3 statements, and you have to determine whether the statement is true or whether it is false. Whether the statement given can be inferred to be true, yes, or it is no. So over here, essentially, you have to infer whether the given statement from the data that is given, what is the actual value or what is the actual calculation from the information given, calculate what is true or not, and then mark the right option. So it is inference from table-based information. In terms of graphical interpretation, you will be given a graph, and then instead of actually figuring out the truth value of a statement, you have to construct a true statement. So over here, you will be given a statement with drop-down boxes. Instead of drop-down boxes, you can look at them as fill in the blank. You have to fill in the blank with the correct value such that the statement overall becomes a true statement. So both cases, you have to essentially figure out what is a true statement, which of the following would lead to a true statement as such. So both of them are in a way analogous as such. The last part is two-part analysis. This I feel is more quant-oriented in many ways. So over here, what you have to essentially do is, you have to essentially find out you will be given a particular question where there will be variables, and you will be given 2 columns, okay, and the 2 columns will have different values. You have to say, okay, say that you get X is for column 1, Y is for column 2. You have to infer which of the following values is correct for X and which of the following values is correct for Y. It becomes easier when you actually take a look at the question. But over here, like data sufficiency, this is mostly quantitative and you have to solve the question essentially to get to the answer. Now let us take a look at each of these type of questions individually. I'll give you an example of each, but you have to essentially remember that what is tested in data insights, what is tested is your ability to find relevant information and infer from it. Okay, so let's get, we'll go to the first type of set that is generally asked, which is most commonly asked is data sufficiency. A lot of you might already be might already know about data sufficiency because these kind of questions used to come in GMAT OG also and come in many other management entrance exams. But if you're not familiar with data sufficiency, no need to worry. I'll explain to you exactly what is there in data sufficiency. So how do you actually think of data sufficiency? Some amount of some quant problem will be given. So either the profit that is there or rate of doing something, time taken for people to meet. So the basis of the problem might be from averages, ratio and proportion, time, speed, distance, time and work, many other things as such. And a question will be asked about it. What is this, or how much time would be taken, etc., etc. So some question will be at the end of it. The key thing to remember is that this question cannot be answered by the information given because there will be some elements that are actually missing in this information given. So if I convert this information into some kind of a linear equation, I will get a linear equation, say that 2x plus y is equal to 40. Okay, and suppose I'm asked what is y. Now y can take a multitude of values. Y can be 40, x can be 0, y can be 38, x can be 1 and so on. So I can't determine the value of y just using the information that is given. Then you have to say that then two additional statements would be given. So here, after you take a look at the paragraph and the question, you are aware what is asked, what is the required information and what information is really needed to get the required information. Over here, if y is needed, what information is really needed to answer what is y? If you get x, you can calculate or put it in the equation and get the value of y. So then you have to see that is either statement 1 or statement 2 supplying me with the value of x. So for example, if we are told that say x is in the range, say we are told that x is in the range of 4 to 10. Okay. Now if x is in the range for 4 to 10, y will also be in a range of different values, which like if x is 4, y will be for 32, and if x is 10, y will be 20. So for this value or this range of x, there's a different range of y. But that would mean that I cannot definitively answer what is that 1 point value of y as such, which means that this information will not be sufficient to answer the given question. Then they can also tell you that x, suppose it is given that x is a perfect cube. Now this information or that x is a perfect cube, how can you use that? So if x is a perfect cube, x can be equal to 1, or it can be equal to 8, or it can be equal to 27, or it can be equal to many things as such. Now if it is if x is equal to 1, y will be equal to 38. If x is equal to 8, y will be equal to 16, so y will be equal to 24. If x is equal to 27, y will be equal to negative or something like that. Suppose you are told for sure that y will not be negative. Or essentially here again we get a multitude of values for y that y can essentially take. But at least there will be, like given this statement, there will be at least different values, multiple values of y which would satisfy this given values of x. Which means that from statement 2 alone also I do not get a single answer. Now the second test is firstly determining is statement 1 alone, is it sufficient? No. Is statement 2 alone, is it sufficient? No. Are these two statements together sufficient? Now I know that x is either 1, 8, 27 and x is between 4 to 10. Therefore, x can take only one value, which is x is equal to 8. If x is equal to 8, y is equal to 24. And therefore, I get the value of y. If I consider both statements together, then I can answer the given question. So essentially, this is the task, okay? Can each statement, is either statement alone sufficient? Is each statement alone sufficient? Are they sufficient together? Or even together they are not sufficient to answer the question. So this is the task that you have to see, that what is the missing information. Once you realize, okay, this information is missing, which of the given statements contains the missing information. Let's take a look at an actual example so that we can then figure out how to solve the questions of this type. So say, let's say Jessica has n chances to hit the target in a shooting competition. The hit rate is defined as the number of times Jessica hits the target divided by the number of times she shoots. She has already taken a few chances, so we don't know how many chances she has already taken. She has 16 more chances to hit the target. If she hits the target in each of the remaining 16 chances, then her overall hit rate would be 50%. What is her current hit rate? So there is currently, suppose she has taken say y chances and her current number of hits is say x. So her current hit rate is x divided by y into 100%. This is what we have to figure out. This information we have to figure out. So we need x and y for that. She has 16 more chances. If she hits all 16 of them, then this 16 plus x plus 16 divided by y plus 16 is equal to 50%. So essentially I can say that x plus 16 is half of y plus 16. Y plus 16 is the total number of chances and x plus 16 will be the total number of hits. So I can say that 2x, so y by 2 minus x is equal to 8. So I get essentially from the information that is given, I get a equation that y by 2 minus x is equal to 8. But I have to find out what is x by y into 100%. So I need a ratio of x and y, which I cannot get from this linear equation because there is a constant also. So because of that constant, I do not get the value of x by y. So this information is not sufficient to answer the question. How do I find out the value of x by y? If either x is given or y is given, then I can find out the value of the other variable and then find out the value of the ratio. So that is the information that is needed. So let's take a look at the sentences given, statements given. So statement 1 is she has missed 28 times till now. She has missed 28 times till now. How many times has she missed? If y is the number of chances and x is the number of hits till now, y minus x is the number of times she has missed till now, and this is given as 28. Y by 2 minus x is 8. Y minus x is 28. So if I change this equation, I can write this as y minus 2x is equal to 16. By solving this by minus plus minus, I can say that x is equal to how much? X is equal to 12. If x is equal to 12, y will be equal to how much? Y will be equal to 40. Therefore, x by y will be 12 by 40 into 100%. So that will be 30%. So I can get the hit rate using statement 1 alone. So 1 alone is sufficient to find out the answer. The second statement is, now when I am actually solving for the second statement, I should always remove all the vestiges of the first statement. So I should not consider any of this information because my second statement I have to consider completely alone, completely separately. I should not confuse this information and assume this information along with information in the second statement. So second statement is the ratio of the number of chances she has taken to the number left is 5:3. So basically that means that the ratio of y, that is the number of chances she has already taken, to the 16 that she has left, this is 5:3. Okay, so using that I can find out some value of y which is not an integer. Using the value of y, I can find out the value of x. Again over here, I think this should be 5:4. Okay, I'll just do that. Now statement 2 tells you that the ratio of the number of chances she has taken to the number that left is say 5:4. 5:3 does not give us an integral value. So suppose that is 5:4. If it is 5:4, it is basically telling you that the number of chances that she has taken till now is y. She has 16 chances left. And this ratio is 5:4, which would mean that y is equal to 20. If y is equal to 20, 20 by 2 is 10. 10 minus x is equal to 8, which would mean that x is equal to 2. So 2 out of 20 shots have been hit. So her overall hit rate till now would be 2 by 20 into 100%, which is essentially 10%. So essentially using either of the statements alone, I can answer the given question. So each statement alone is sufficient. So this is basically how you answer. Get the initial equation down, then see, okay, I take statement 1 alone. Is it supplying me with the variables that are missing? Can I find out the required variable? If I can find out, yes, this statement alone is sufficient. Consider the second statement. Is it supplying me with the missing variables? Yes, then it is sufficient. Suppose that both are not supplying with the missing variables. Consider both of them together. So sometimes you might not have x from either of the statements, but together they can give you the value of x. Then you would say that both statements together are sufficient while neither alone is sufficient. So that is basically how you solve data sufficiency questions. This is in many way a quant question. But the thing to remember over here is that this does not require you to get at the actual answer. So I found out what is the value of y, I found out the value of x. But the point is that you don't need to determine the value of x and y. Using statement 1 alone, I could figure out, okay, y minus x is there, y by 2 minus x is there, 2 equations, 2 variables, I can definitely solve it to get to the answer. Which means that I should not actually solve it to get to the answer. I can determine the answer, that alone is sufficient. Second statement also tells me what is the value of y, and that alone is sufficient to get to the answer. So the point to remember in data sufficiency is that you have to determine whether an answer can be reached. You do not need to actually solve and get the answer because it is not required. Okay, so this is basically how you solve the data sufficiency questions. Now let's take a look at multi-source reasoning. As I mentioned, in multi-source reasoning, you will have tabs of information. So there will be some information in tab 1, some information in tab 2, some information in tab 3. You have to go through all the 3 tabs to get to the full information, and then from the combined information of 3 tabs, you have to answer a set of questions. Generally, the issue over here is that there is so much information. There will be a paragraph over here, there will be like some charts over here, some pie chart, there will be some tables over here or a bar chart over here. There's a lot of information that is there, and you have to use all that information to actually consider, okay, from this pie chart, combine this pie chart and line chart and infer from it together. So multi-source reasoning requires you to first find out the relevant information and then combine it together to get to the real answer. Okay, I'll give you an example to actually see how to solve these kind of questions. So consider this. This is from the sample set given in sample question given in GMAT website. So the first email is, yesterday was the deadline for a receipt of completed surveys from doctors who were invited to participate in the medical practices priorities survey. Did we get enough returns from this original group of invitees to get reliable statistics? Do we need to invite additional participants? So the project coordinator in response to the administrator says, altogether we got 350 actual survey completions. We need at least 700 and we're hoping for even more. So we plan to invite a second group to participate. Both the results from this first group and the second and the other research indicates that this type of survey and this type of participants, there is about 40% probability that any given invitee will submit the completed survey in the time will allow. Obviously, that doesn't mean that if we invite 100,000, we'll necessarily get at least 400. So we need to think in terms of risks of getting too few returns or exceeding the budget. All of the participants who submitted their surveys by the deadline will get a $50 payment. We promise. What is our total budget for compensation to participate? So here we are told that there is a 40% chance individually that somebody will actually respond. But it does not mean that only 40%, exactly 40% of the invitees will respond. So it's not that you give 1000 and you'll get exactly 400, or you will definitely get 400 if you give 1000. Sometimes if you give 1000, all 1000 might reply. Sometimes if you give 1000, 0 might reply. But essentially the probability that 0 will reply will be very little, and similarly the probability that all 1000 will reply will also be very little, because essentially when you are considering that each individual has 40% probability, the chance that exactly it will be around that 40% will be the highest. Deviating from the 40% will be lower, deviating towards 0% will also be lower. So the probability would be somewhat like a bell-shaped probability with near 0 at the ends as such. The budget we allocated for compensation of those who completed and submit the medical practice survey is 45,000. We will honor a commitment to pay $50 to each participant in the second group as well as first, who completes the survey and submits it by the deadline we specify when we invite them to participate. However, we will need to try not to exceed the total amount that is budgeted for this purpose. So here you have 45,000 and you're going to pay 50 per invitee, which means that you can pay about 900 of these submissions without exceeding the budget. If the number of submissions goes above 900, you will exceed the budget as such. So this is the information we have till now. Now all of this information, read it, absorb it, understand it, and then go to the questions. So the first question, the question that we are asked is, consider each of the following statements. Does the information in the 3 emails support the inference as stated? The administrator is unwilling to invite as many participants in the second group as were invited in the first group. This cannot be supported. In fact, the administrator is saying that we need at least 700, which means that we need at least 350 to confirm, because 350 from the first group, we need at least 350 from the second group. So he definitely wants to actually get enough submissions from the second group such that he reaches his 700. target, as well as he does not really exceed the overall this of 900. So that means that he wants the total value to be somewhere between 700 to 900, and there is nothing to indicate that he is not willing to invite as many in the second group as the first group. So this would be no. We can't say that he's unwilling to this, because in his position you would have to at least invite as many, if not more, to make sure that you hit the 700 mark. The project coordinator does not expect to be able to meet the goal for numbers of completed surveys received. The project coordinator does actually expect to meet it. He is just saying that we will have to adjust how many people we send out the invitation such that we meet the goal but don't exceed the budget. So this is also not true. He is saying that there's a balance to be achieved. He is not saying that this is impossible. The administrator is willing to accept some risk of exceeding the budget for compensating participants. Over here, just look at this particular part where he says that we will honor our commitment to pay $50 each for each participant for those he completes the survey and submits in the deadline this. So the budget is 45,000, but even if it exceeds, we will definitely honor our commitment. So suppose if you, instead of getting 900 responses, suppose you get 950 responses, then also the administrator is ready to pay for those 50 extra responses. He is taking that whoever gives it, we will honor our commitment as such. So it is not that he does not expect to pay. He is ready to accept the risk that there might be an excess number of submissions and you might end up exceeding the budget as such. So this is true as such. So this is yes. So here, as you can see, it required no data crunching. It was just simple inference based questions from the simple information that is given. So let's take a look at the next question based on this. So suppose that the total number of invitees in the second group is 560. So we have 350, we have to pay them $50. That is already done. The next group has 560 people. If all the information in the 3 emails is accurate, the probability that the budget for compensating participants will exceed is nearest to. So if all say 560 respond back with a yes, then you will have 350 plus 560. You will have 910 people responding yes, which would mean that you had budget for 900 people, you will be exceeding by 10 people, which means that you would be exceeding by $500. But this is in the extreme case where all 560 respond yes. We know that this is around like a normal curve. Most of them would be 40% of them will actually respond with a yes. 100% responding yes would be a very low probability. Similarly, 0% responding yes is also a low probability event. So the probability that you will exceed the budget, where the budget allocation is for 900 people, is in the very extreme scenario where at least more than 550 of these 560 people actually respond yes. So 550 out of 560 responding yes, when the probability of each individual actually responding is 40%, is a very low probability event. It would be basically, if you consider binomial distribution, it would be 560 C 550. The probability of them saying yes being 0.4 raised to 550 and 0.6 raised to this would be 10. So this would be a very low probability event by binomial theorem. You don't need to actually calculate by even just considering the curve. This event where mostly you expect 40% to come, and even if it actually is a slightly this, you get more than expected, less than expected, you still won't expect all 100% to come as such. Which means that given that this is a very low probability event, the probability that you will actually overshoot the budget is near 0. So the correct answer would be option E. It would be about 0% probability that you will actually exceed the budget. It would be like 0.1, 0.2 or even lesser than that. Okay. Now let's go to the this 0.1, 0.2 would actually mean the 0.1%, 0.2% as such. Very low probability, not 0.2 as in 20%, not like that. It would be very low probability that you will actually exceed the budget. Now let's consider the different type of set, which is the table analysis. So table analysis, what you will generally be given is that you will be given a table which has multiple columns, and this table is a special kind of table. This is a sortable table such that you can decide that okay, sort by column 1, sort by column 2, sort by column 3, sort by column 4, and by doing that you can try to identify what are the trends in the given table as such. You can use the sorting to figure out what would be the average of a particular column. You can figure out what would be the median by using the sorting mechanism. So all of these things become easier if you actually use the sorting mechanism. Based on this kind of table and sorting, you have to figure out whether a statement is true or not true from that particular table analysis. So let us take a look at an example so that we understand how to actually do table analysis. Consider the table, okay? This displays data on Brazilian agricultural products in 2009. So you are given the commodity, so you can sort by commodity, you can sort by production world share, production world rank, exports world share, and exports world rank. So this is the information that is provided. A lot of information is provided. Based on this, you have to tell whether a particular statement is true or false, or yes or no. For each of the following statements, select yes if the statement can be shown to be true based on the information in the table, otherwise select no. So no, the statement is no individual country produces more than 1/4 of the world sugar. So basically, let us figure out what information is there about sugar. So consider the information that is there about sugar. The production of Brazil's share is 21%. It produces 21% of the world sugar. Its production world rank is 1. So at 21%, it is the largest producer of sugar. If the largest producer of sugar is at 21%, the remaining producers of sugar should be at less than or equal to 21%. So if you consider the table of people who produce world sugar, it would be 21, 20 or something, a decreasing list like that, which would mean that all of these are less than 25%. So no individual country actually makes more than 25% or a quarter of the world's production of sugar. So from this information is sufficient to say yes, no individual country produces more than 1/4 of the world's sugar, because all of them, even the largest producer makes only 21%. Nobody even comes near 25%. So this is yes. If Brazil produces less than 20% of the world supply of any commodity listed in the table, Brazil is not the world's top exporter of that commodity. Let's go back to the table and see. So if it produces less than 20%, so it produces less than 20% of beef and chicken, of corn and cotton, and of pork as such. In all of these cases, its production value is less than 20%. Now it is said that in these cases, it is not the top exporter of that particular So it is mentioned that in these particular cases, it is not the world's top exporter of that commodity. So let us say, it is not rank 1 in all of these cases. Let's see whether that is the case. In both of these cases, it is rank 1. In this, it is not rank 1. Over here also, it is not rank 1. But for beef and chicken, while the production world share is less than 20%, it is actually the world rank 1 in exporting, which means that this is not true. This statement is not true because Brazil is the world's top exporter of beef and chicken. So this is no. Of the commodities in the table for which Brazil ranks first in world exports, Brazil produces more than 20% of the world supply. This is just a restatement of that. For both beef and chicken, we have seen that while it is a world exporter, it produces less than 20% of it produces 16 and 15%. So this is also no. This is essentially a restatement of statement B. So both of them are false. So over here, what essentially had to do, did you have to do a lot of calculation? No, you didn't have to do anything really. Based on the table that is given, you have to find out what is the relevant information and say whether this is a true statement or a false statement. Not a lot of calculation involved, just a lot of thinking involved as such. Now let's take a look at the next type of this, which is graphical interpretation. Over here, I'll directly go to the question because it will be easier to understand what is graphics interpretation from looking at the question directly. This is the sample question that is given in GMAT. Basically, over here, we have to use the graph to infer which statement would be true based on it. There are basically, it's like a fill in the blanks with one of the options that is given, and you have to look at the graph and figure out which of the values in the given values is correct for the blank that is given. So if you look at the graph over here, you have air temperature and water temperature. The graph at the left is a scatter plot with 40 points, each representing the temperature of the ocean water measured at a fixed location of the coast of West Iceland, and the air temperature measured on land at a fixed location in West Iceland. Both the water temperature and the air temperature in degrees Celsius were measured at noon on Wednesday of each of the 40 consecutive weeks last year. The solid line is the regression line and the dashed line is the line through points 0 and 6. So the dashed line is basically x equal to y as such. That is, the air temperature is equal to water temperature. Points above that indicate air temperature is greater than water temperature. Points below the line indicate that water temperature is greater than air temperature. The line, regression line, what does it show? This regression line essentially shows the correlation between x and y. if you see a line like this, what is the angle made by this theta angle made with the positive x-axis? If the angle made by the positive x-axis is a acute angle, okay, if it's an acute angle, basically you can say that if it is an acute angle and you can draw a line like this which is sloping upwards, you can say that there is positive correlation. As air temperature increases, water temperature increases and vice versa. So in these cases, when you see that, okay, this is a line which is sloping upwards and it is making an acute angle with the x-axis, it is positive correlation. On the other hand, if I had gotten a line like this, the angle made would be an obtuse angle more than 90 degrees. In that case, it would be negative correlation. If I had a vertical line, in that case, I would say that there is no real regression, no correlation, and they are uncorrelated. In this case, because I get a positively sloping line, I can say that these two, water temperature and air temperature, are positively correlated. I can visually see that this line is sloping like this, and from that I can infer. The relationship between water temperature and air temperature is positive. The slope of regression line, is it less than, greater than or equal to the slope of the dashed line? This is the slope, okay, and this is the slope of this line. Is this line slope flatter or more curved, more arched than the given line x is equal to y? It is flatter, it is closer to this, right? This is basically, it's a flat regression. This is basically equal regression. If it is slightly lesser than equal regression, it is flatter than the x is equal to y line, which means that this regression line slope is less than the slope of the dashed line. It is entirely visual inference. There is no calculation involved. You have to look at the graph and learn from it. So these are the different parts of data insights. I hope I have demystified data insights for you, and I will see you again and I will try to go deeper into each of these different parts. Thank you for tuning in.